Hello everyone. Thank you for joining. My name is Caroline, and today I would like to give you an introduction and a demonstration of our developed service of marine lit assessment within the iMagine project. Just a quick overview of what our service or use case actually does. So our goal is to analyze drone footage RGB images with two convolutional neural networks to detect and quantify plastic litter floating on the water surface. What the service provides is shown in the frame on the right. So the service expects or accepts RGB drone footage and analyzes that in two steps. At first, the plastic litter detection, so the PLD convolutional neural network, splits the image in tiles of size 128 by 128, and each of these cut tiles are classified with the first model, leading to the results on the left. I will show you a better quality example in a second. But what you can see in the first results on the left here is the lighter and darker gray shades. This indicates that these tiles are classified as litter high or litter low, depending on the quantity of items that are found. And in a second step, these results are fed into the second convolutional neural network in the plastic litter quantification, the PLQ model. This model or this step splits the identified litter tiles again in 64 by 64 pixel size tiles, and then classifies these smaller tiles into the different litter categories. This is what it looks like in better quality. So this is the input that the service expects, RGB drone footage, ideally of an altitude of 12 meters. And yeah, the first step gives you this result where in a broader resolution, different environmental classes are classified, as well as the two litter classes. And as I said before, the classes that have been identified as litter are classified again with the PIQ model and giving you a somewhat wide variety of different litter classes that the model can distinguish. And on top of these visual results, the model also gives or generates an Excel sheet. So Cambodia Wise, that's the name of the image. And these are the labels and the classification results of the first model, the plastic litter detection. And as I said, in the second step, in a more detailed resolution, the different litter classes are classified, and also their number of classifications are summarized in the Excel sheet. Okay, and now that I showed you how or what outputs the service produces, I would like to show you, give an overview how you can use the service to produce your own analyzed remote sensing images. So there are different modes of operation. The whole code, which consists of the pre-processing steps, the classification itself, as well as the post-processing, is available on GitHub. I'll show you this in a second, but here's already the link to our GitHub page. This entire setup is also wrapped up for convenience in one Docker image. I will show you in a second how to set that up so you can run the service locally. If you don't want to run this locally and you would like to use external resources, the Docker wrap-up is basically the backend for using the service on the iMagine marketplace and the integration to Oscar. And if you only want to use the service as an input-output, you want to input the images and get your results back and not have anything to do with the background, it's very easy to use MinIO. I will show you this in a second as well. But basically, you only insert your images that triggers the AI, which the user doesn't need to worry about, and gets the results back. Okay, then I will already start showing you and additional information of so this is the service website, and it might be worth mentioning that we have some standard operation procedures, how to do the drone surveys that the service can operate with. So the target spatial resolution is 0.5 centimeters per pixels. Depending on the type of drone you use, that depends, that shows the altitude. And yeah, we also gave some recommendations on our experiences of drone and sensor combinations and the suggested altitudes to produce the right images for the service. We also included scripts in the Git repository that I will also show you how to retrain your model. So if you can't completely or produce images that have the right spatial resolution or very different environmental conditions, then it might be worth retraining the model. But I will get into that in a second. And yeah, in general, a remark, if you have any questions how to use the service, feel free to contact us. Okay, then I can dive right into how to use the service. So the Git repository that I showed you the link from or shared the link before basically contains everything that's needed to run inference, but also retrain the models. In the following demonstration, I will just go through the different steps, starting from the deployment, going to the inference, and finishing with how to retrain the models. So for deployment, there are two different ways if you want to run the model or the service locally. I wouldn't recommend it, but you can deploy the whole service locally. Make sure that you do this in a virtual environment. Basically, you clone the Git repository, install the package, and then start the API. But I would like to show you how to do this in Docker. So just to make sure that all the requirements are fulfilled. So in the first step, the image is downloaded or pulled from the Docker Hub. I won't do this right now because it will take some time. So I downloaded or pulled the Docker image already, but I will show you how it works when you have the image pulled and just want to run the container based on this image. So you basically just copy this, plug it in, and what this does, it starts the API that is basically a wrapper for the model. It opens a local port, and this is the very baseline way to use the service. So this opens the API. What's relevant for us is for the inference is the predict endpoint. You can click the try out button, browse for your file. This is the same image that I showed you before. I will stick with this image throughout this demonstration to give you an example. So once this is uploaded, the settings you can change is whether you want the plastic litter detection plot. We want this for now. The plastic litter quantification plot, we also want this. The service also has the possibility to run a face detection on each of the individual ties before analyzing it with the CNN models. We don't want this right now because it will take too much time just for this demonstration, but just to note that it's possible. Yeah, we also want to get the results as a zip file, click execute, then that triggers the AI models and will give us the results in a second. Okay, it's quite slow, but here, yeah, you can also see the progress. These are the different tiles that are being analyzed. In the first step, the detection, and then in a second step, the quantification, which is a little faster. Yeah, and once this is done, you can see here as the response to download the file. This will download the file as a zip file. And the zip file contains basically everything that I showed you before. One plot for the plastic litter detection, indicating where there is litter present in a broader resolution. Based on this, the plastic litter quantification, distinguishing the identified tiles of litter in a higher resolution in these different litter classes, and the summary of the PLD and PLQ model in a an Excel table. So you have one part here for the litter detection and one for the litter quantification. And the differentiation here between classification and assessed abundances, if you can read this, is that the classification just gives you the number of classified tiles, and the assessed abundances is the altitude corrected amount of the corresponding litter label. So this is what we're aiming for. This is the results, and there are just different ways on how to get them. Okay, so this was the very minimal running this with the API. Also, you can, instead of ingesting individual images, you can also upload zip files, and it will then go or iterate through the different images in the zip file and give you one Excel sheet with the different columns indicating the different images that were inputted. Okay, so this was you come back to here. So I showed you how to do the local deployment and also how to do the inference. So for the local deployment, whether you do this in the first described way or the second demonstrated way with Docker, this both opens up this Swagger UI running the inference as I showed you just then. So this is the inference local deployment. There's also the chance, if you don't want to deploy the service locally, to use the cloud service supported by or integrated in Oscar. First, you need to register to the with this link here, but once that's set up under this link, you can access the Oscar service. This is the landing page. It basically shows you all the different developed services and the Docker image that's behind it. So what's relevant for us is the UC litter assessment right over here. And yeah, the service itself is triggered by the buckets. So also for this bucket, they are connected to the different services. And so again, the relevant bucket for our use case is, or our service is the UC litter assessment. There's an input and output bucket. And basically in the input bucket, you can upload your file. Again, the example of the Cambodia waste. And by uploading, this triggers both models, basically the same as with the API part or the Swagger UI that I showed you before. And once the model is done, you can find the resulting zip file in the output folder. Now here, it's a little difficult at the moment to find, because there's no timestamp, at least none that I can find, which zip file corresponds to your current run. So I should suggest to use MinIO that's built on top of Oscar. It's the same buckets, it's just a different interface. So the landing page of MinIO looks like this. Again, here are the different buckets. The one relevant for our use case is the UC litter assessment. And again, we have the same structure of input-output. If we go to input, we can see that just then this image was uploaded, the Cambodia Waste 2. And if we go to the output buckets, I don't think it will be done just yet, but if we go by last modified, okay, well, I can use this because this is the one that I uploaded just before the webinar. Yeah, but this is, again, the same content. So if you click download, this will result in the exact same things that I showed before. The plastic litter detection plot, the plastic litter quantification plot, and the Excel sheet containing the results. So this is the most hands-off way if you just want to input your images and get the demonstrated results back. Okay, oh yeah, one note at this point. As you can see, all the buckets are somewhat publicly available, so everyone who has access to Oscar and MinIO in that matter, so all the different services available. If you have images or just don't want your data displayed like this, there is a chance to get private buckets. For this, you would have to contact us. Yeah, and then we can set it up. It's pretty straightforward, but this needs a bit of manual setting up, but it's definitely possible, and hopefully doesn't hinder you to use the service. Okay. And so the images that I showed so far contained like large litter carpets and more or less always green vegetation. If you have images that are very, very different, so for instance, contain sparsely distributed litter items or contain different environmental conditions like ice or non-green vegetation, it might be worth retraining the model. Or if you have varying litter types that should be analyzed or classified. We included 2 scripts or Jupyter notebooks for training both models, the litter quantification as well as the detection. I will give the example how to run them with the quantification. It's the exact same setup though, so that should be straightforward. So to show you, so the whole module is also available on the iMagine marketplace. The module is the litter assessment, and especially for retraining, it's nice to use the marketplace. It's pretty straightforward and it has the Jupyter setup integrated anyways. So I will show you now how to set up a deployment of this service to retrain the models. So if you're on this landing page or page of this litter assessment module, you can either deploy the model by Inference API plus UI, or what's even easier, if you go to Codespaces and go straight to opening it in JupyterLab. So here are the different deployment options. I will just do the demo webinar, a password that you have to remember to access the Jupyter notebook later. Yeah, you can decide whether you want the Jupyter setup or for inference also the Deep RS API. This will basically open the same Swagger user interface that I showed you before. Okay, then we go to the next step, and here you can set the hardware options. For training, we do need 1 GPU, but other than that, it's pretty resource efficient, so don't need that much. In the next step, you can choose the storage configuration. So if you just basically link your data set, yeah. Once we submit that, we can find the deployment in the tasks and under deployments. I already have 1 instance running. So if we access this, so this is starting it. It takes a while, so I will use the one that I set up before. If we go to the Jupyter notebook, okay, then this is the whole Git repo that I showed you before. It contains all the API part, but what's interesting for us now is the 2 training folders. So as I said before, I would like to give you the example of the litter quantification, but for the litter detection, it's the exact same setup. So in the folder of the litter quantification, we have different subfolders. The configs, this is 1 file that you would need to change. This contains the labels. And so label old means the labels that the model has been previously trained with. These should not be changed because then the model can't load properly. And label new, you can set it up with your own labels if you have new ones. If you only want to change the data but with the same labels, then that's also fine. But yeah, if you do modify the labels themselves, this is a file that you need to change. And another part to mention is the data file. So in the Git repo, this is just a placeholder empty file. You do need to fill the data folder with your own data, and the way this should look is also explained in the Git README. So under the data folder, the subfolders should be the different classes. So class 0, I don't know, litter type 1, litter type 2, and the folders themselves then contain the images numbered. So this is the setup what the data folder should look like. And these class names have to correspond to the YAML file that I showed before with the labels new. Okay, then back to the deployment. Yeah, once that's changed and you uploaded your data, we can go into the Jupyter notebook, the training quantification notebook. And this is the basic, the notebook that runs the training. So it first imports the libraries, it defines the different methods. For training, it loads a model, modifies it, runs the common training and validation steps, also testing at the end of the final model. Another thing here is the data augmentation techniques, so the train transforms and chess transforms. This is just a suggestion. We added some other augmentation techniques that we didn't use but might be worth using with new data. And yeah, then the main script for running the training, it contains all the paths. They do not have to be changed. And once the training is done, it saves the new model under new model under the models dictionary folder. And so the first step is it downloads the already pre-trained model. The model is currently stored under Nextcloud, but it will be downloaded, saved under models, and then be modified. The other hyperparameters or parameters that you can change for training are these, so the number of epochs, the learning rate, batch size, and num workers, as well as potentially the optimizer. We're currently using the Atom optimizer and maybe the loss function. But other than this, or other than that, these all contain, this is the code that contains everything you need for rerunning the training on the pre-trained DenseNet. And yeah, this saves the model, and then after, so I won't run this right now because it's gonna take too long, but the new model is saved under models, and it can also, so the dataset is divided into 3 parts, and at the end there's also this script that tests the newly trained model. And as I said, the exact same is also there for the litter detection model.